Hello everyone, welcome to my pathfinding game. In this video, I'm gonna be showing you how to play the game as well as explain the A-star algorithm that powers the game. So let's run it. In this game, you will be the submarine here, and you will try to reach the treasure, which is the gold bar here. And on the way to the treasure, you will have to avoid lava, which is the red cell here. And let me first tell you how the game works. So you press I to open the instructions for the game. Press I. You will see here left click to place the lava. Also, you can edit the cell cost by press hold control and then left click on any cell to change it. And to set the treasure location, you will right click on your mouse. And to set the submarine start, you can middle click on your mouse to do it. After you're done with all that, you can hit the space bar to find the path to the treasure. Uh, you can reset by pressing the button R, and that's basically how the game works. Uh, let me now let me explain a little bit about the A-star algorithm. So now let's get into the backbone of the game, the A-star algorithm. So in here you can see these three lines are for calculating the F value of the star. These are for creating a priority queue, and we will insert the start first into the priority queue. And also we put the start in the open set first in here. So this loop is the main thing. Um, uh, at each iteration, we will pop the node with the lowest F value. So you can see current here, and then we discard it from the open set. Uh, this if condition is when we find the goal. So once we find the goal, we will reconstruct the path and then calculate total cost. If we haven't found the path yet, we will continue with these lines of code here. So the current node will be added to the closed, and then we don't have to care about it again. Um, we will then get the neighbors of their current node. If a neighbor is already enclosed, we just skip over it. And this line is for next up, we will calculate the G score of the neighbor. And if the G score, if the tentative G is smaller than the current G score of the neighbor, we will change the parent change the parent of the neighbor to the current node, and then update the G score of the neighbor to the tentative G. And then next we will calculate H score and then F score. And if neighbor hasn't been in the open set yet, we have to put it in the open set. So in here, you can see the neighbor is put into the open PQ and then open set. And finally, if we don't find anything, just return a tuple of none and none. So yeah, that's basically how the algorithm works. Now let's try to play the game. So I will place the lava here. I will randomly do it. You can see the game found a, an optimal path for the submarine, which cost 84. Let's try that again. It will say no route found because our submarine cannot move diagonally if it is blocked by their cardinal neighbors, which in this case are the right and the down neighbors. Let, let's try to put the submarine here and then the treasure in here, and then edit this right here to 1, which is the smallest value. So so the path should be this one here. Go right and go down, and then go diagonally from here, and then diagonal again, and then go straight to the gold. So let's try to run it. As you can see, it will follow the path or where every cell on it costs only 1. Uh, Thank you for watching. Hello everyone. Welcome to my project Connect 4 with Monte-Carlo tree search. Uh, Let me first explain the rule of the game. So the board has 7 columns and 6 rows, and players will take turns dropping a piece into a column. The piece will go to the lowest available space, and whoever can connect 4 in a row will win the game, whether they are vertical, horizontal, or diagonal. It's also worth mentioning that in this game, I added a feature where you can go back to the previous move if you wish. Like in here, if I play this column, and then if I regret it, I can press U to undo it. So let's try to press U. So you can see it has been undone, and I can play the move again. And the game is playable in 2 modes, human versus AI and AI versus AI. In the human versus AI, we will play red and AI will play yellow. In AI versus AI, uh, we will just let the 2 AIs play against each other. And so uh, let me first explain the Monte Carlo tree search. Uh, so the algorithm can be broken down into 4 main steps. Um, Selection, expansion, simulation, and backpropagation. Now I'm gonna go into detail for each of these steps. So first, the selection, we select the best child, and let's see the best child function. Um, so in here, if child visits equals 0, it will be automatically the child will be automatically returned because Monte-Carlo search tree Monte-Carlo tree search guarantees that each step will be explored at least once. And next, we will see this line right here. It means that we are looking at the opponent's perspective. So we have to try to maximize this, which means minimize this, which belongs to the opponent. Um, and this is just some standard UCB formula. And next, we will get to the expansion. So in this step, we uh, we just get the legal moves, compare them with the tried moves, and then see which ones are not tried yet. And then this line will pick a random move from them. Next up is the simulation step. For this simulation, we will have a helper function called rollout, which will play a random game until the terminal state. And one thing worth noting in here is I prefer the center columns in here. So this line means that the closer a move is to the center, the um, the the bigger the weight will be. For example, if move is 3, which is the center column, then this will be 4. This weight will be 4, which is the max value. And finally, we will come to the back propagation step. So in this step, we just simply go backward from where we are to all the way to the root. And at each step, we increase visits by 1, increase reward, and then we have to flip it uh, for the parent, because parent and children represent um, the opposite perspective. Finally, at the end of the algorithm, we will return the child with the most visits. Um, so let's go to the game and let's try to play a game with AI. Now I'm gonna try to play against the AI. I'm gonna play seriously this time to see if the AI is strong enough to defeat me. So I won the game. Now let's see what happens if two AIs play against each other. As you can see, the first AI wins. Thank you for watching.